Welcome to the Industrial IoT Spotlight, your number one spot for insight from industrial IoT thought leaders who are transforming businesses today. With your host, Eric Walenza.
Welcome back to the Industrial IoT Spotlight podcast. I'm your host, Eric Walenza, CEO of IoT One, the consultancy that helps companies create value from data to accelerate growth. And our guest today is Ricardo Gilead Baibich, CTO of Kando. Kando is an end-to-end solution that creates continuous awareness of events for water utilities to remotely and continuously improve their operations. In this talk, we discuss the unique challenges faced by utilities due to their complexity and their inability to control the inputs into their systems. We also explored how IoT and machine learning analytics can provide visibility to control health risks, reduce energy and maintenance costs, and improve insight into population trends. If you find these conversations valuable, please leave us a comment and a 5-star review. And if you'd like to share your company's story or recommend a speaker, you can email us at team@iot1.com. Finally, if you have an IoT research, strategy, or training initiative that you'd like to discuss, please email me directly at erik.walenza@iot1.com. Thank you. Ricardo, thank you for joining us today.
Hi, Eric. Thank you for having me in the podcast.
Great. So, Ricardo, I got to ask, first of all, you've got a bit of an accent. I know you're sitting in Israel, but you have a nickname that's a bit more Latino. Where are you from?
Yes, so I'm Ricardo, but a lot of people call me Caco. I'm from Brazil. I am 22, 23 years living in Israel now, but yes, I'm a Brazilian living in Israel doing wastewater.
Yeah, it's funny because I looked at your CV, and whenever somebody's from Israel, I always look at the bottom and I look, what's their military experience? Because sometimes they have this kind of interesting background of, they were working with a special division, and I didn't see that on yours. So then I was thinking, okay, curious. Certainly not Israeli.
Yes, so yes.
But you do have a very interesting background, and I'm curious how this kind of led you then to join Kando, because Kando is a very specific field that you're in, this wastewater field. When did you first touch the topic of wastewater, or how did that come on your radar?
Yeah, so I think it's more of the water, energy, food, and now climate nexus, which I am doing for the last 23 years. And it comes with connecting digitalizing this world, right? So bringing IoT data collection and acquisition, analysis, geographical information systems to try understand, tackle these problems. I come from the technology side. So I studied, I'm a software engineer, but I play with Legos from really early, right? And basic programming, logo programming, and then C. And so I think that coming to Israel and which here, this is a topic which is really of national importance, I think, right? So kind of connected me with this, wow, I can do this and that, and this is one, right? So I came to, I'm the CTO at Kando for the last almost 5 years. But prior to that, I was also working on precise agriculture and sensing and distributed sensing systems. So yes, I think that water is something that we don't even understand as we as people, how important it is to us, right? And we don't pay enough attention to it. So it's kind of a mission now.
Yeah, fantastic. Well, I'm glad to hear that your journey started with Legos. I've got a 2-year-old who's just getting into them now, and I hope eventually he ends up as a CTO somewhere down the line and can reflect back on his, where it all started. But it's really interesting that you mentioned that this is kind of national importance. So I'm sitting here in Shanghai, and we're just at the end of the Yangtze River, and it rains a lot. So here, water, it's definitely a big topic because there's a lot of pollution, and it's a huge city, so obviously it's important from that perspective. But I guess for Israel and countries that are very arid, it has an entirely different perspective, which is really kind of a national security almost. So let's talk about why is this such a critical topic? What are the different perspectives that make water management an important topic?
I think that when I focus on the wastewater part of it, right? So of course that the droughts and the world we see, having potable water is getting more and more expensive, right? Energy wise and the sources and etc. But we as humans are generating tons of waste per day in cities, and that we are dumping as waste and also as wastewater. Now, this wastewater, it has to be collected, it has to be treated, it has to be ideally reclaimed and reused as water, as resources, because a lot of stuff is in there, right? What happens today is that this water sometimes is just returned to the river with minimal treatment, if at all, and so on. It is a water cycle. So in the end, this water we are dumping, we are drinking it back, if by actively repurposing the water or if by dumping back into the water cycle, and it will come back to us, right? The microplastics in the oceans and the pollution that we create. So it's not, it's a matter of survival, I think, for humans to be able to manage our this expensive resource, this imperative resource for life that is water. And wastewater collection and treatment is a huge part of it that we don't hear about it every day in the news. It's like underground, but it's like impressive when you go and see these people doing managing these huge networks of thousands of kilometers of pipings under our feet, right, every day, and doing this work. And there's where we are trying to help these authorities, municipal, state-wise, federal-wise authorities that have to collect all this wastewater and treat it and try to keep the public health and protecting the environment, while also doing that in a timely and financially possible manner, right? Because it's expensive to do so. So it's a right.
So when you talk about the value of data here, where I guess we could look at this from different perspectives. So part of it is kind of the quality of the water at different points. I guess there's also, as you just mentioned, a lot of very expensive infrastructure here. And so there's kind of potentially an infrastructure maintenance perspective. What are the points where you see the biggest challenges today in terms of managing this wastewater infrastructure?
Mm-hmm. So yes, what we are focusing in when talking about the infrastructure itself, right? Because we tell you in a bit that in the end we understand that what we do is wastewater intelligence. There's more into the wastewater than only the water and the things you can recover. There's a lot of information about what's happening overground. And now we really truly understand that and can give this information and insights as actionable insights to a number of things, not only the management of the water network itself, right, of the wastewater network itself, but yes, focusing on the wastewater network or the collection and treatment of the wastewater. So the treatment, there is this treatment station, generally speaking, right? This big treatment station that collects the wastewater from the city. And there is a big factory that has raw material wastewater and has to put out clean water, right? In different levels, depending on the kind of treatment plant and the purpose of the water in the end. So some cities today in the US are already talking about drinking potable water from wastewater, right? So doing the full cycle. So some are actually doing that already in pilot phases, but really doing that. So in Israel, most of the water goes to irrigation. So it's also the fruits we eat. The watermelons now in the summer, it's 80-something% wastewater in the end. So yes, the thing today is that the collection network until now was a big question mark. So people knew that they are getting this raw material in their factory, the treatment plant. They have to do something about it, but they are just now finding out what it is. So it's a hard thing to do. They have to over-engineer. They have to have backups over backups. It's a hard work. So we understood that by being able to see what's happening in the network, we can help these people know what's coming, prepare for it, optimize their work, right? There are biological processes in the way, so it's important to know how to improve. And at the same time, when looking into the network, we are able to see the sources of these anomalies, of these, right, pollution events. So we are able to pinpoint them and help the authorities go and discuss and talk, even legally do something about it. There are regulations, but our focus and our understanding is that it's much better to talk and discuss and fix the problem. A lot of times it's not bad people, right? It's something that went off in a process and nobody knew. So we are seeing that it can be fixed and it's for the greater good, even cheaper for everybody in the end.
So that's fascinating, because I am coming a bit more from a manufacturing background, right? And I've never really thought about this before in detail, right? But I suppose a wastewater facility, it's very much a process plant, right? And it's a process plant that has, I guess, you just mentioned a unique set of challenges that most don't have, right? So if I'm a chemical plant, or if I'm a beverage manufacturer, I basically know what my inputs are, and I very tightly control them. And if I have a new supplier, I know who that supplier is. And so you can really optimize that. I guess with this, it's doing a lot of similar things in terms of processing liquids and filtering and so forth. But you don't have so great control about the inputs, as you just said. You might have a factory release something that they haven't released before, or you might have a flood event, or you might have a pandemic with a bunch of people sick all of a sudden. And these are all, I suppose, new inputs into the water that you didn't have before. I've never really thought about that. It's a very interesting perspective.
Yes, so it's a lot of, and I come also from the industrial IoT before it's called IoT, right? So it is, and it's a big, looking like that, the city itself is a big, big, big factory plant, right? With all the sources, and they all come to this central place. It is a big challenge because in the end, you don't want to have, or you would like to maybe, but it's tens of thousands of kilometers of piping, right? Really complex network. So what we try to do here is to bring AI and edge and cloud to have this ability of put something that is manageable, right? You don't want thousands of units if you can have hundreds and maybe tens, right? Depending on the kind of IoT unit and sensing that you need at the same place. And a lot of machine learning on the side of understanding the data and understanding the geospatial data. So it is a big challenge that I think that yes, few have seen it as that before, right? As of course the treatment plant as a process is something that people work for decades, but the collection system itself was a bit neglected, I think, on that side of the technologies, right? And the services, the offerings for these new kind of technologies can help. From the infrastructure itself, so some factories, when discharging some things, create an environment that allow bacteria to really eat the concrete. And then you have this piping that disappear with time, to the problems of the amount of organic matters and heavy metals that you may have in the sewage that get to the treatment plant and really make the process much more expensive, if not impossible sometimes. So you hear about those extreme events that crash the treatment plant, and really they have to restart the whole thing, and it may take weeks to restart the whole thing. So imagine that during those weeks they are overflowing untreated almost. So these are extreme events, but they happen. So we are, in a sense, kind of helping them have a bit of visibility on those, right? Because as you said, it's like a big factory, and they don't know the prime raw material they are getting, the sources. Now they have a bit of the visibility, and we use a number of dashboards and data analysis to create these actionable insights, right? In the end, is the idea of reducing the energy, the CO2, right? The greenhouse gas is generated by using this energy and so on.
So we have this very complex system. say I flush the toilet in my apartment, and that water goes through a lot of different pipes and infrastructure before it ends up wherever it ends up. Where along this path are you collecting data? How close to the, let's say, to the supply, to the household and the factory? Are you trying to collect it at entry points and do sampling there, or are there specific points in the process where it's aggregated and you do sampling, or are you more sampling the end product and trying to do kind of a quality assessment there? Where do you do the sampling along this path?
So the sampling happens in all the network, not in households, right? So it's not, I think you could say, and then about the pandemic, which is another thing we started doing, but then it's more on community level. When talking about industrial discharges, so sometimes, yes, there are units in front of a specific factory. But these are different kinds of customers as well, right? For the water utilities that are managing. So these have permits of how much of every kind of material they can discharge. And then they are being monitored and worked with to make sure everybody's on permit. When sampling for example, something we started in the pandemic is that this understanding that you can see the COVID virus in wastewater, and then sequentially more than that, that you can see detect future pandemics. You can understand levels of population diet and population diabetes and all kinds of endemics, right? So there it's the same system but working on a community level. It is an aggregate level to be able to understand this exactly this aggregate level, right? So it can be used from the source. It makes sense to use it for the specific use cases in different parts. So when talking industrial sewage, I think it's always a good idea to have this big visibility of everything. So we try to monitor the bigger industrial areas as areas, but then we have this ability of high definition in an area, right? So going in and zooming in with more units and more capabilities to pinpoint exactly and understand exactly what's going on. And the system always suggesting where to, right? So the system, by learning what's happening, is now asking for more details in specific areas.
You mentioned a couple interesting things here, and I'm trying to just get a sense of where we are in the market. So you mentioned, for example, being able to track things like obesity across maybe a community or across a city, so where there's a higher prevalence or lower. And then I'm imagining fairly precise and unique sensors to do that sampling. Whereas, if you just asked me yesterday, what kind of sensors do they have in a water facility, I would assume it's temperature and its acidity and maybe, a couple other things that are kind of blunt instruments for doing kind of general testing. But now you're talking about quite specific things. What can you just share? What is the typical status quo sensing equipment in an average, wastewater facility in Israel or in the U.S.? And then where do you see there being potential? I guess it sounds like you're working with some facilities that are now really taking a few steps forward in terms of going into more granular detail. But what's the status quo in the average facility, and then we can start getting into the more interesting areas to extend that.
Yes. So to make it clear here, and I think this is maybe the thing, is that not everything we are measuring is online sensors on water or on the media, right? So there are different data velocities, if you will. So we have sensors that are touching the water, measuring all the time. We have sensors that we call remote, but they are in the pipe, not touching the medium. We have sensors that are outside in some research stations, which the water is being pumped out, checked and sensed, and then put it back into the same place. And we have samplers, right? So even in the sampler family, there is the grab sampling and spot sampling, meaning a sensor saw something of interest, we take a sample. So it's really a pump filling a bottle that goes to a lab, right? When I talk about public health, community health, And we talk about the COVID project, for example, that is being today measured, I think, in every treatment plant, at least in the US. I think the CDC has a program, right, for this grab sampling and measuring in the lab. It's a sensor. It's not an online sensor. So we got the sample to the lab. These are where the specifics, those that right? When talking about the online sensors in the sewage, and specifically in the collection system, because the collection system you don't have power and right, and you have a hard time transmitting data. So there is where we identified as the most challenging place, right? That would bring the benefit. And there we are measuring more of macro. So you're right, temperature is one, electroconductivity, pH. There are a number of parameters that can and are being measured depending on the exact application, but not those really parts per billion things you only find in a lab, right? What do we do have as part of the IoT kit is a sampler. So the sampler is activated or works in different modes of work. It can do a composite sampling. It can do a full day sampling. It can do a spot, right, in an event sampling, right? So that's how the system works by leveraging all these different data velocities on open source data as well, but of course on the a big part of the hardware system and the field system is to bring this first hand data set, right? So it's data that comes from the sewage. We assume we not necessarily are using only sensors in the sewage. Lab samples is also a part of it. Of course, not for the real time alerts, right? So the system has these fingerprints. So we know for a lot of kinds of pollution events that we have them on the samples in the lab and know exactly what they look like. We have these fingerprints, these models that can say, hey, this is happening now, right? So we don't have to have another sample to prove that this is what's happening. And then we can use the sensors to give us this visibility without having to sample all the time.
Okay, understood. So you identify specific factors that correlate with an event, and then you can just track those instead of doing the lab sampling. So I think I have a pretty good understanding of your kind of value proposition. So it's almost I guess it's on the one hand visibility in terms of what is in the system and where there might be issues, and then operational excellence in terms of how do you as a system reduce energy consumption, improve quality output, maybe improve, reduce capex spend by understanding where pipes are eroding and where not, and so forth. So you have this kind of putting the data to use to accomplish these goals. Let's then talk a little bit more about what Kando is doing here. So are you a system integrator? Are you providing kind of the full stack from hardware to the integration to the visualization software and the AI, or are you more of a technology provider that is providing the software and kind of working with integrators who do the hardware installations and so forth? What is Kando's role in this putting the system together?
Yeah, so we are working with public authorities, with municipalities, with water utilities, and we provide a service, or we are a service provider. The whole service we can provide. We leverage sometimes our hardware and sometimes it's data from the customer. There is this hybrid mode. We work with local partners, so we have this team locally maintaining the system. So it's kind of all on us, right? We provide the actionable insights, and we make all the things that have to happen behind the scenes happen. Regarding the hardware itself, so we design things, but we do not produce hardware, right? So we buy sensors, we design and then buy the unit itself. We are not a hardware company per se. We work with our system is agnostic to the hardware, so we work with data from customers, being it from sensors or historical systems. We leverage open source data, and of course the data we acquire, right, for the project, depending on the situation, what needs to be done and how, with accordance with the customer. So we are working with the authorities and local partners in that sense.
Yeah, great. So you're providing you're wrapping this up as a service, and then it sounds like you're able to provide the hardware if needed, but you would buy that from manufacturers. You provide the service, you provide the software. Is there a lot of I'm sure there's legacy sensors on the software side. Is there already a lot of legacy software that you have to integrate with or work around, or are a lot of these companies? I mean, I guess there is to some extent. Like, what is that legacy environment look like from the software side?
Yes, I'm not sure we have a lot of touch points with legacy software as we have data interfaces, right? So we have this cloud system. So our customers go in the cloud in a website where they have this application where they see their dashboards and maps and events, and they can understand what's happening, right? Different levels of decision making in the end. We do have, of course, APIs both from data from the customers from different systems. I wouldn't necessarily call them legacy, but also right. But I think this technical part is not really the problem most of the time. And of course, to be able to also provide our insights as not only in the website as dashboards, but also as data, right, for other systems to integrate and use. So I always see that the real challenge there is the data product definitions rather than the real technical software writing interfaces, right? I think the engineers normally find common ground easier, if you
Mm.
will. Uh, but yes, I wouldn't put it as a big challenge, but it's something that happens, of course. I think we see it in all the industries now more and more that this open data thing, this at least standardized data.
Then, if we look at that question of, yeah, how do you make use of the data? Who would be the typical users here? Because I guess you have quite a few functions within the facility itself that could make use of this data, and then also external stakeholders that would also want access to the data. So, what does the user profile usually look like? And maybe we can also cover kind of the buyer profile. So, where's the budget coming from, and then who are the users of the analysis?
So regarding the public health project, let's call them. So these are public health organizations, as in Israel, the national infrastructure. So we are providing data there and the dashboards for public authorities to really decision makers, right? Policymakers, decision makers. This is regarding sampling for COVID now and wastewater based epidemiology or public health through wastewater intelligence. The case of for the utilities, so the collection system that the utility manages, they have this operational team that they do sample, and they do have this pre-treatment team going around and trying to find the problems and the quality and the permits and so on, right? So this is one team that is gaining a lot of value from the system and working with the system. At the same time, the people treating in the water treatment plant, the wastewater treatment plant, they are also gaining. So these dashboards are made for both the both teams and in different levels of real time slash decision, right? So they are use case specific. So there's a difference between looking for a specific event that comes from a specific factory right now and in 4 hours getting to the treatment plant, right? And between looking into the monthly discharge pattern of an area. Both are valid use cases in the system that have the tools to be done. So the water utility is different depending where in the world. So water utility can be a municipal authority, can be a municipality that owns the utility. Some places in the world they are private companies. Some places they are public or half or hybrid, right? But they are the ones responsible for collecting and then treating, or collecting and someone else is treating this wastewater. So these are the customers. And again, for the public health part of it is more of health departments, municipal, state-wise, federal, but health departments. These are the stakeholders and policymakers, right, using the system. So looking to from operational opex and really reducing energy and materials and labor to decisions in public health now with the public community health. So it is has become really diverse.
Do you work at all with industry, with chemical plants or other plants that are using a lot of water and have a lot of wastewater issues, or are you more or less 100% focused on municipalities?
Yeah. So yes, we don't. So with specific industries is not something that we did with like one factory or something like that. This is not where we are. Some big compounds, right? So you have these industrial parks, which if you look into them, they are like mini cities with a huge industrial presence, right? So these are places that have a big enough network, I would say, right? Or the need to really have this intelligence, not only because it's not only measuring one point. For measuring one point in the process inside the factory, I'm not sure we have something special, right? So there are a lot of sensors that are made to be on pressurized pipes with the right specifically for process monitoring. So we are after that. We are looking from the first municipal point in the network to the treatment plant, right? Really the collection network. So where you have collection networks, we can and work with. So more bigger compounds, industrial compounds, but not a specific industry like one factory. Right?
Gotcha. Okay. Yeah, maybe we can just look at one or two case studies. Just, I think it'd be interesting to kind of walk through a couple use cases here, right? So, what were the problems, and then how did they end up addressing those? Any interesting ones come to mind?
Yes, so I think that to showcase or to talk about different kinds of the use or two of the use cases. So we have, for example, one of the interesting ones in the U.S., El Paso, Texas, where they are. So we are deployed there and really seeing the results. And they have this big treatment plant. They have a lot of industry, a lot of petrochemicals that are heavy, and they are building a beautiful project of water reuse, potable water reuse. So using this wastewater and water and then making drinkable water, right? So they are using us there and we are helping them there because you cannot do that without knowing the sources and what's coming, right? It's not, it's really people will be drinking that, right? And it's really, really interesting. I think because of showcases the importance, right, of source control, of really understanding what's happening there to be able, it's an enabler of something that important. So this is a interesting one. I think that in Italy in general, right, but we see that in they have these operators that operate a number of treatment plants. So there is also this interesting case of looking into comparing plants and looking into the comparison of cities. But more specifically on these places, the problem is always regarding metals, the industrial areas and metals in the sludge, because when you treat the water, then you have this sludge that if it's not class A, for example, and can be reused for creating biogas even, it has to be disposed as toxic waste. So it costs them hundreds of dollars per ton, right, to dispose these thousands of tons of waste being produced. And the other option is to have a high quality enough sludge that you can produce biogas from it, or you can even make them into fertilizers, as in Israel is done with a lot of it, right? And then in some cases, you have not only people not paying for disposal, but getting paid for the sludge, right? It's a big operational cost that can even be turned into a right operational gain here. It's a combination of the amount of the pollution and the kind of the pollution, right? And you so in this project, specific project in Italia, we yes, you know what? Sorry for the specific project in Italia because I'm not sure now which one of them, but the project in Italian. And this project in Italia, so they reported a almost 30% gain in electricity after using the system, coming and talking to the polluters and lowering the level of specific factories, and then being able to lower the electricity use by almost 30%. So it's huge.
Right, the electricity use in
In the treatment plant.
in the treatment. Okay, interesting. So
Yes,
by
yes.
asking the factories to better control the inputs into the plant.
Yeah, so by making sure the factories are on permit, right,
Okay.
and are working as they should, then you have you are producing less loads, pollution loads, and the loads are less toxic, right? So it's easier to deal with. I'm simplifying, right? So the toxic and right. So it's a huge area in itself of how wastewater is treated, and it's a big industrial process, right? So we are trying to help here, really give this heads up in a way of what's coming and how to optimize them. So having this information you can optimize from one hand, but in the other hand, and at the same time, saying, hey, it's not only by optimizing the process and knowing what you're getting, you have a way of changing the inputs. You can talk to those factories and you can agree on some, and you can then have better inputs as well, right? So it's fitting the cycle of the economics here, right? For both saving the environment at the same time better treating the water that will come back in the cycle to us, right? Whenever whatever we do with that water, in the end, it's in the water cycle, and it will be back. So I'd rather have it clean and safe.
Yeah, absolutely. Well, and water is becoming ever more precious, right? So this is it's one of those issues where you know that the ROI, the benefit, is only increasing year after year. I think we've covered a good bit of territory here, Ricardo. Anything that we haven't touched on yet that would be important to share with folks?
Well, I think that really this it comes back in the end really in this thing of the impact we are trying to do, right? So it's really trying to not only do but only and help others do, but I think it's about a change of how we think as humans, right?
You just a quick question on that last point. So how we think, I mean, not to insult any of your customers, but governments are not universally considered to be the most forward thinking in terms of kind of using technical solutions to solve problems. That maybe that's unfair, but I think that's at least a kind of a stereotype. But how have you found kind of receptiveness to having more data driven?
I think it's a great question, and I think that you'd be surprised about the water people, because these people do embrace innovation and do embrace technology because they understand that there's no other way. So you see it across the board with the water people, right? So from desalination to water treatment, drinking water treatment, wastewater treatment, they're all the time looking for the next. At the same time, and you're totally right, and these guys are right as authorities and public authorities to be risk averse. So it's not they are not innovative, but they cannot allow themselves the risk of failure, right? They have this responsibility. We chose them to be there and have these responsibilities. They're not allowed to have this kind of failure. So this is a challenge that I think we are kind of a risk management tool as well. We are a kind of a risk insurance as well, right? So we are monitoring exactly that. So it hasn't been hard for us, I think, to have this understanding from customer side, because we are also kind of, yes, we have to know what's happening to really manage risks, right? So I think I kind of agree that you think about like public authorities or right, and policymakers as conservative on the technological side, and I think it's more of risk averse than not innovative. So we work hard on it to show and to prove that what our AI systems say is true, right? By first and when coming to a new customer and showing samples and validating the data and yes, and I think it's a good thing that they are the gatekeepers of that, right? They are right to require that rigorous systems, right? That there are not a new idea and right and just an idea, but something proven technology. So it was a challenge, but we in these last years, right? So we have like billions of gallons of water under our sensors and hundreds of thousands of lab samples, and I don't know how many, right? So after so many data, I can say with confidence. So yes, I think it's risk averse more than not innovative in the tech. And I think it's important from us, industrial suppliers, technical, right, technology suppliers and service suppliers, to also understand that it's our responsibility to prove, right, that is that and the risk management around it. It's an important part of it.
No, that's a great perspective. Actually, I think it's easy for technologists to point the finger and say, you're too afraid to, or you're too slow to adopt new technology. But of course, yeah, they're not, the technologist is not the one that's on the line if something goes wrong, right? It's the operator or the politicians also behind them. So it makes sense to be and obviously, yeah, this is such a sensitive topic that.
Yeah. In my experience is always working together and having this talk with the customers and being open and partners, right? So we want the same good together, and it does work. I think that I see, right, how the water people, at least, which I can talk about when I see them. I think it's a huge shout out because in the end we are all drinking this water and we go to the bathroom and everything works, right? It's under our feet, but people are working hard every day.
It's remarkable. Yeah, it's really the hidden luxury that we all live with and don't think about. Well, Ricardo, thank you so much for taking the time to share this with us today. Maybe just last question then would be, how can folks get in touch with you or with the team if they want to learn more about what you're doing at Kando?
Yes, Eric, thank you so much for having me. Well, Kando.eco, first of all, and I'm there on the LinkedIn's and on the website, so everybody can write, and we'll be more than happy to talk and listen and
All right, perfect. Well, thank you, Ricardo.
Excellent. Thank you so much, Eric. Thank you.
Thanks for tuning in to another edition of the Industrial IoT Spotlight. Don't forget to follow us on Twitter at IoT1HQ and to check out our database of case studies on IoT1.com. If you have unique insight or a project deployment story to share, we'd love to feature you on a future edition. Write us at eric.walenza@iot1.com.